In this video, we're going to be looking at the Argand diagram. We're going to be looking at how to represent complex numbers on the Argand diagram. So there are some few things to note here. First of all, the Argand diagram is used to represent complex numbers in 2D plane. By that we mean just the x and y plane, right? The plane with just x and y axis. Secondly, the x axis, the Argand diagram represents the real the real part, and then the y-axis present the imaginary part. Look at it over here. So that is it. So now, for instance, we also have to know how to identify complex numbers. Which part of the Argand diagram do they belong to? Now, the Argand diagram here has four quadrants. We have first quadrant, second quadrant, third quadrant, and we have the fourth quadrant. So the Argand diagram has four quadrants. So how do we know how to represent these numbers in the quadrant respectively? So let's look at it this way. If a complex number is of this form, x plus iy, if a complex number is of this form, x plus iy, where the real part is positive and the imaginary part is positive, then such a complex number belongs to the first quadrant of the Argand diagram. And then also, if the complex number is of this point, of this nature minus x plus iy, then such a complex number represented with on the Argand diagram would be on the second quadrant. Likewise, if you have z to be equal to, let me change the ink. If you have z, if you have z to be equal to minus x minus iy, then that complex number when brought to that Argand diagram is going to be in the third quadrant, right? So if you have also z to be equal to x minus iy, then such a complex number is going to be presented in the fourth quadrant of the Argand diagram. So we are going to I'm going to be writing out some complex number and we are going to be putting them in the Argand diagram. That is, we are going to be plotting them on the diagram to know where they belong to. So if we are to represent these complex numbers on the Argand diagram, the first one at the far right, top right hand side, we are going to have this is z equal to 2 plus 3. I remember here everything is positive, both the x and the y axis are positive. Then on the x, this representing your x plane, and on the x axis, and this representing your y axis. On the y axis, let's mark 3 to be here. You have 3 here. And on the x axis, let's mark 2 to be here. You have 2 here, right? So this is what you have. So you have to draw it. You are going to draw it this way, right? It's going to represent your 3, and this is your 2 here. This 2 is here. So the distance from here to here is 3, and the distance from here to here is 2. So this is what it means. This is the representation on the Argand diagram. So now you have to represent the second one, this number 2. You have to represent it on the Argand diagram. You are going to take minus 2 to be this side. This is your x. Let me write it here. You have z to be equal to minus 2 plus 3i. You're going to take this to be minus 2, and the 3 is going to still be here. So drawing this line here, taking this 3 here, this is your theta here, this is your angle. So z is equal to this. So let's now look at the third quadrant, right? Now third quadrant, this represents the third quadrant. So you have your x to be minus 2. X is minus 2, so we're taking this still. But then your y now is minus 3, so let's take minus 3 here. still minus 3 here. So if you draw this, right, and you take your theta to be here, let's take this to be minus 3. So this is the representation of this on that Argand diagram. So let's go to the last one. Let's go to the last one where you have z to be equal to 2 minus 3i. Present z equal to minus 3i in the Argand diagram. This is your x as usual, and this is your y. So we are going to have minus 3 here, this distance. Then we are still taking this 2, this distance. So if you draw this line, right, and take your angle is minus 3. So this is a representation of this on the Argand diagram. So in the next video, we are going to look at modulus of complex numbers. Modulus of complex numbers.